back to part 2 of getting ASCOM set up and configured to control your astrophotography gear. In this video I'm going to go through the configuration and setup of the astronomy programs that we installed in part 1 and show you how ASCOM glues these systems together and works together to provide a nice and seamless experience when imaging the night sky. Okay, let's crack on. The first thing we're going to do though is not ASCOM related. We're going to configure our plate solving software. So if you remember, in part 1 we downloaded PlateSolve 2 and AllSky Plate Solver. So let's start with PlateSolve 2 because it only takes a couple of minutes. When we launch PlateSolve 2 we need to go to File and Configure Catalog Directories. And here it's asking us for where our APM and where our UCAC3 folders are. This is why we made a note of them in part 1 of the video series. So let's select our APM folder, which is in C Program Files x86 Starry Ridge APM, and we get a message or a status of OK, indicating it found the necessary files. And then the UCAC3 one we installed here, we unzipped the file there because there was no installation, if you remember. So if we go find our PlateSolve and then we go there, and we get the same message of OK status indicating it found the necessary files. And we just close that dialog and close this dialog. That's PlateSolve 2 done. We then need to configure AllSky Plate Solver. This does it in a slightly different way. This will connect to the internet on demand the first time we run it and download the files that we need. And you can see there when I've launched the program, it tells me that the indexes are not found. I want to download them now, so I'm going to say yes. And it starts the index installation wizard. The index installation wizard requires a few things, as it doesn't want to download the entire catalogue. It just wants to download the ones that are applicable to your focal length and your camera sensor size. So we have to give it some values here. So for the purpose of the demonstration, I'm going to say that my telescope focal length is 550, and then it wants this pixel size and the dimensions of my camera in pixels. If you don't know this, your manufacturer's website will almost certainly have this documented. So let's say for the purpose of this demonstration, my camera is a ZWO ASI 071MC. We would go onto the ZWO website and we would find the cooled cameras section. Here is the catalogue of cameras they do, and here's the camera that for the purpose of the demonstration I'm going to say we've got. And when we click on that, we go to the specification tab. We can see our pixel size and our dimensions of our sensor in pixels, and those are the values that it wants here. Alternatively, if we've already taken a picture with this camera, we can get the information from a header in a FITS file. FITS file is a very popular format that a lot of astronomy programs use to capture images in, and I've downloaded one and put onto this PC, and this is when I took last year. In fact, it was in 2019, but it was with that camera, and it fills in those details for me. And then importantly, over here on the left, it tells you which index files need to be downloaded. Just for informational, because all you need to do down here is say install indexes highlighted, and off it will go. This will take a few minutes, so I will skip forward and I'll see you in a few seconds when this is finished. Okay, the index files are finished installing, and press OK, and then we press done, and then it asks you if you want to register. It's free, and we'll just say no at this moment in time, and it starts up AllSky Plate Solver, and we can just press exit for the moment. So that's both the plate solving tools configured. We're now going to look at using APT to connect us to some ASCOM equipment, namely our camera, our mount and our focuser. So when APT starts, it asks us that our site location is not set, so we'll just say no for the moment, and it starts it with a checklist wizard, which we'll just say OK on. For the purpose of the demonstration, we're going to connect to not a real camera but a simulator. So for all intents and purposes it's the same as connecting to a camera, apart from it's not actually real. So under the camera tab in APT we have a connect button, and it asks us what the camera type is. We've got standard DSLR, Canon and Nikon, and then we have an option to pick an ASCOM or a native driver. So some camera manufacturers offer native drivers that are not ASCOM. SGP, for example, have just retired ZWO native driver support, and they only support it through ASCOM. As this video is concentrating on ASCOM, we were just going to pick ASCOM, and we'll press OK. And then it comes up with the all-important chooser. The chooser dialog you'll see with a lot of ASCOM when you're configuring things for the first time. So when you choose a focuser, you'll get a chooser for the focuser. When you configure a mount, you'll get a chooser for the mount. When you choose a filter wheel, you'll get a chooser for the filter wheel. So when we pull down our list of available cameras, you'll notice there's 2 ASI cameras in there. The only reason they're there is because we installed the ASI camera ASCOM drivers in part 1. If we hadn't have done that, those 2 would not be present. As I say, I'm going to use a simulator, and I have to press the properties tab. This properties tab will be different depending on the driver and the camera that you've picked on your chooser. Don't worry about what you just saw there, it's just so that I can set up the simulator to take images of the pretend sky that I'm looking at. Then we're going to press OK. In your settings box there'll be things like what gain to use as a default, maybe what the if the dew heater, if it's got one, can be turned on or off, and things like that. It will be different depending on what camera and what manufacturer. So I'm now configured and connected to my ASCOM camera. I'm just going to set these settings here, which this is not an APT demonstration, but it's just so I can quickly take some images with this virtual camera. The next thing I'm going to do is I'm going to go to the gear tab, and this is where in APT you can configure your mount, your focuser, your filter wheel, and rotator. So I'm going to connect to my virtual mount. So again, when we come into this list, you'll notice that there is the Stellarium telescope driver and the EQ mod drivers. Those are only present because we installed the ASCOM driver in part 1. If we hadn't have done that, this list would have not contained them. For the purpose of demonstration, I'm going to pick a simulator for my mount, and we'll press OK. We're now connected to our mount. So this is now talking from APT through ASCOM to the ASCOM driver to the actual hardware. In my case, virtual hardware. I'm going to do the same for the focuser, and you'll see that in the focuser list we have a Stellarium focuser and a ZWO focuser. The only reason those are there is because we installed the drivers for ASCOM in part 1. So hopefully you'll see that as you install your ASCOM drivers, they appear in the chooser for the particular piece of hardware that you're trying to set up. I'm going to pick simulator again, and we'll press OK. So we've now got our camera connected, and we've got our mount, we've got our focuser, all connected via ASCOM. I'm going to minimize this, and then I'm going to go into Stellarium, and we're going to connect to our mount as well in Stellarium using ASCOM. And we're going to do this whilst APT is still connected to the mount. So when we fire up Stellarium, which is our planetarium software, this is the night sky based on my current position and my time of what I could see in my back garden right now. So over on the left hand side we need to go to configuration, because by default Stellarium does not allow you to control telescopes or mounts unless you enable the plugin. And under the plugins list there is one called telescope control, and we need to say load at startup. Now this is a little bit annoying from a Stellarium point of view, is I can't configure this no matter how many times I try and click this. We have to make sure we've clicked load at startup, close that and quit out of Stellarium, and then go back in. We will then be able to press that configure button. So back in Stellarium, go to configuration, we go to plugins, we scroll down, telescope control, and we can now press configure. And in here we need to add the type of mount that we're wanting to connect to, and as you can see there is now an option for an ASCOM mount. We can give our telescope a name purely for the purposes of Stellarium, and I'm also going to pick start and connect at startup, and then we're going to choose our ASCOM mount, and you'll see the same choose a list. It's the exactly same dialog box. So in my example I'm going to choose the telescope simulator and press OK, and we're going to press OK, and I'm going to press connect. Oh look, right, that's where it thinks my telescope, my virtual mount and telescope are currently pointing to. The important thing to realise at this point is, if I get them both on the screen at the same time, I'll have to minimise these and whiz them around a little bit, just bear with me, is both the APT program and the Stellarium program are connected to the same piece of hardware through the same ASCOM interface, both at the same time. One last thing I'm going to do in Stellarium, I'm just going to make this full screen because it's easier, is I'm going to enable something called remote control. Remote control is not remote control of your mount or your equipment. This is purely to allow you to allow another piece of software to control Stellarium. And I've got to do the same thing. I've got to tick enable load at startup, and then I've got to go back in if I want to configure that. And you'll see why we do this in Stellarium in a second. So I'm going to go back to our plugins, remote control, configure, server enabled. We get a message saying I'm trying to talk on the network, do you want to allow it? Say yes. And then I'm going to say enable this at startup, save settings on exit, close that plugin, close that window, and then we'll just minimize Stellarium for the moment. So back in APT, if we go to the tools section and APT settings, we can tell APT which planetarium software we're going to use, and we want to tell it we're using Stellarium. That remote control setting we've just set, you don't need to worry about what these numbers are, it's the IP address and the port number. This is what allows APT to talk to Stellarium. If we hadn't enabled remote control, APT would not have been allowed to talk to it. I'm just going to press OK. Okay, let's get funky. So we bring back up Stellarium, push it over here. We'll go back to our gear tab so we can see the array, the deck, the alt and the as that we're currently pointing at. And this is the virtual handset, hand controller for my simulator. These should all be pointing at the same numbers because they're all talking to the same ASCOM driver, which is talking to the same ASCOM piece of hardware. So one of the features in Stellarium is we can get it to slew our mount. So let's go to Arcturus. If I go there and press Control and 1, hopefully this will work. Watch these values here and these values here. I think it had to go over the meridian to get there. So you'll have seen they both changed at the same time because they're all talking to the same ASCOM driver. Let's try and make this a little bit more fun. So let's go somewhere else. Let's find something such as the pinwheel galaxy. So if I zoom in to Stellarium, just to show that that's where we are looking, there's the pinwheel galaxy. I'm going to press Control and 1, which is tell Stellarium to slew, and we can see telescope slewing there, and our deck and RA are moving. So with Stellarium pointing there, I'm going to minimize it, and I'm going to bring back up APT, and then I'm going to go to my camera. Now you'll notice I've got 1 second exposures. If only this was the case. This is purely because I'm using a simulator. I can do this. When I hit shoot, we should get, fingers crossed, a picture of what we're looking at, and that's a pinwheel galaxy. The only reason we're seeing this is because I'm using simulation of the sky as well, which is quite clever. So we've controlled our mount through 2 pieces of software, and we have taken a picture. So just to prove that that wasn't some pre-setup, we will pick somewhere else. I don't know, let's pick this is the North American nebula here. So if I just put my thing in there and press Control and 1, off it goes, slewing away. We should get the telescope reticule appearing in a second. There it is. You can also see in, I don't know if you saw there in APT, it said slewing. So they're all talking to each other. Let's minimize that, bring that up. Let's take another picture, quick one shot. And we should see the North American nebula. Probably very, yes, so that's what I thought. It was quite a zoomed in area of the nebula. So that's really basic controlling your mount and your camera through ASCOM. Let's have a quick look at something to do with plate solving that isn't ASCOM related, but as we've set things up, we may as well go through that. So I'm just going to randomly pick a place in the night sky, but I'm going to put it somewhere near where we will recognize a very bright star. Let's see if we can find Vega somewhere. On its own. I don't know why I'm trying to find it manually. I should just go Vega. Hopefully it's in, right, there we go. So it's what, in the northeast of the sky. So I'm just going to zoom in a bit into Vega. I'm going to tell Stellarium to slew. Hopefully that will be in the field of view there. Hit Control and 1. Off it goes. You'll see in APT it says slewing. If we go to the gear tab, the coordinates are all changing. Looks like it's finished because it's stopped slewing. Just let it settle. And then I'm going to take a picture again. Ooh, now, which one of these is our bright star? Could it be that one? Could it be this one? I'm not entirely sure. It might not even be any of those. In fact, this could be the edge of the glare of Vega. So let's go to gear and go to point craft. Point craft is the feature inside APT which allows you to do plate solving. And if you remember from part 1, plate solving is the ability for software to look at an image and work out what it's pointing at. Now, even though we've set up our plate solving software, we have to tell PointCraft with inside APT where those pieces of software are. So if we go to the settings tab, you'll see here it wants to know where the PlateSolve2 path is. So this is where the programs have been installed. Now, if you remember, we put PlateSolve2 in Astro PlateSolve2. We don't pick the catalog, we just pick the PlateSolve2.28 folder, which is where the executables are. And then it wants to know where the All Sky Plate Solver path is. And again, this isn't where the catalog's gone, but where the actual software is installed. And this is in Program Files x86 Plate Solver. And we'll press OK. And then we'll press OK. I'm going to do a plate solve, but not a blind plate solve, and I'll come on to what that is in a second. So I'm just going to tell Pointcraft where the approximate scope position is, and I'm going to hit solve, and fingers crossed. This here says it's trying to solve this image, and it says success. Fantastic news. So what does that actually mean? Well, it means it knows what it's looking at in the night sky, but I don't know what it's looking at. So because we configured Stellarium in our planetarium section here, we can press the show button, and you'll see down here it says sent to Stellarium the field of view, orientation and the telescope image position. So let's have a look. I've just minimized it. This is what Stellarium is looking at, and I was correct. So the glow of Vega is actually this glow down here. We've got this double, which must be these two here. Okay, so I could either re-slew to Vega, or I can do something like this. Let's actually say this was the star that I wanted to be in the center of my field of view. If my alignment of my scope wasn't spot on, I'd have to nudge things left and right and north and south. However, I can get Pointcraft to do it for me. So once we've solved an image, if we go down to here, the center field of view section, and press the solved button, it puts in the solved coordinates, and then I can press aim, and it brings up this little bullseye, and then I can aim at that just by clicking and then pressing go to, and it says, do you want me to sync the scope position with the solved image? We'll just say yes for the purposes. What that's actually doing is moving the scope, and it's going to try and get where we aimed at into the center of field of view. And the way it'll do that is it'll move the scope, and as you'll see, it's just taken another image. It'll download that image now, and then it will plate solve it again. So again, it's slewing because it's not inside the tolerances of what we've told it, which is a few, I think it's 50 pixels. It's doing another solve. Success. It's moving the mount again. And again, the reason it's moving the mount is because we are connected to the mount using ASCOM. Ooh, that looks like a big refraction spike off Vega, I guess. It's done a final plate solve, and I'm going to guess this will finish now. Yep, looks like it's finished. And then if we hit show now, I'm fairly happy that that's where I told it to go. We're going to Stellarium. That hasn't moved. Not sure why. Try that again. I'll just move Stellarium away, and I'll hit show again. Oh, it has, sorry. There is something there. There's the bright star, my mistake. I thought it was the centre of the telescope reticule. So that's a little bit of plate solving and APT. So let's just have a quick recap. We connected our camera, our ASCOM camera in APT. We connected our focuser, we connected our scope, and then importantly, we connected another program, and we told that program to also connect to the ASCOM driver as well. So we had multiple programs talking to the same equipment. That's the same principle for all of ASCOM throughout. Multiple programs will talk to the same drivers at the same time. Okay, well, that's the end of the video. So thanks for watching, and I hope to see you soon. Stay safe. Catch you soon. Bye-bye now.